Okay, this is nothing but grouping and merging. Okay, we have seen frame and world frame, parent frame. The parent frame, if the object is that, if the object is set as child of an another object, for example, child of another object, if we change the parameters of cuboids on a parent object, it will impact the child object. Okay. Okay. Now we will enter into object properties. One of the very important thing in the CoppeliaSim. Okay. Okay. Already I have created something. Okay. Okay. Here it will be new scene, new scene, new scene. If you want, you can add like this. Okay. Now this is a sphere,
Sure.
right?
Sorry for the interruption.
Uh,
Sri Gayatri have asked where to use this all this application point of.
application. Okay.
Yeah,
If
like
we,
when to
for
use
example,
grouping and when to use merging, like that she's asking.
if you want to, if you want, for example, some complex structures will be there, complex shapes will be there. The complex shapes will be like it will be like cuboid plus sphere. For example, mm, I will tell something.
Yeah,
Basketball goal.
I
mm,
guess they'll use grouping in our further task even, I guess.
yeah,
How to use.
grouping. Yeah, it is, but because I didn't check that one because we won't use grouping and merging for the task. But I will explain why where we are using. For example, if we need to build on basketball goal, if we are putting a goal using in basketball, no, for that we need to create complex shapes. Okay, we need to add cuboid plus cylinder like this. Okay, for that, uh, for this application we can use this. But you can see here this manipulator. In this complex shapes we can use grouping and merging. Wherever we need some complex operation and complex shape, something like some edges like this, from where we can use this grouping and merging.
Okay, thank you.
Okay, thank you. Okay, okay, where I stop. Okay, now this is sphere and cuboid. Okay, okay, object properties. Yeah, I forgot object properties. Using object properties. Okay, I will explain by. Okay, this is cuboid. We have created. Double click this icon, cuboid icon. You will get this. Okay, okay. If we want to change the color, or else if we want to we change the texture of this object, we can alter. For example, click color and go to ambient diffuse component, and we can change the color. We want red means, okay, RGB. We all know, I think. Okay, red, green, blue. Okay, we can do like this. Okay, and if you want to change the texture means, for example, if I chose sphere. If I want to change the texture of the sphere means texture, and go to select texture from existing textures. Click only one texture will be existing here. Okay, tiled content, select it and okay. You can see the variation. The texture will be changed. Yeah, texture was changed. Okay, this is how we can use like this. Okay, now we are going to use see dynamic properties. Click on dynamic properties. You will see this body is respondable, body is dynamic. This will be playing major role in comparison simulator software. Why? Because before entering into it, I will explain pure objects and non-pure objects. Pure object in the sense it is nothing but if the object is both respondable and dynamic, it is called pure object. If the object is not non-respondable and static, it is not dynamic means it will be non-pure object. Okay. I think you guys are aware of dynamic. Dynamic in the sense it can for example in the cuboid is set as dynamic means it can mobile, it can move. Okay, but it will be it's in static means it will be in the rest. Okay, okay. This is dynamic and static. If body is respondable, what is respondable? It can detect a collision. For example, if yeah, okay. If I set this cuboid as a respondable object, it can collide with another object. Okay, it will allow itself with collide with another object. For example, this is sphere, this is cuboid, this is respondable now. It will be it will collide. It will make collision with another object. But if it is not respondable means it will not uh, mm, make any collisions. I will show here. Wait, go to dynamic properties. If I if it is not respondable, I'm yeah, it is not respond now. It is not respondable, but it is dynamic. It can move. Okay, okay, not respondable. Okay, now I am just doing simulation. Going to do simulation. See what happens. Okay, where is the cuboid? It gone. Why? The floor is an considered an object. The cuboid is also object. I have selected the cuboid as respondable, non-respondable object. It won't make collision with another object. That's why it fall down by gravity. Okay, okay. Now uh, this is nothing but difference between non-respondable and respondable objects. I will tell, for example, I will stop simulation first. Okay. Now again double click the icon and we have seen. Okay. Now the body is respondable, but it is not dynamic. Okay, wow. It is static. Abdina, which means it won't move. Okay, it will be rest. Okay, wow. Okay. If the body is non-respondable, but it is static, no, it won't move. Okay, wow. If the body is it will be static means it won't move.
Noted.
What? Hello? Someone is, you have any doubts? Okay. 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 We will try it. Okay. Now, okay. This is what respondable, non-respondable, static, and dynamic. Okay, ba? Okay. Now, I am going to do some simulation here. Wait. I am just going to translate these two objects about z-axis. Why? Okay. Yeah. Correct. Okay. Okay. I settled it. Now I am going to add on plane just to give some dimension. 5 cross 5. Sorry. Wait a minute. 5 cross 5. Enter. Okay. The plane has been added. Why I gave 5 cross 5 means it will be cover entire floor area. Okay, wow. It will be useful to see the understand. Okay. Can align like this and okay. Now I am going to tilt this plane. For that I need to rotate na rotate. Am I right? Okay. For that world frame about world frame rotation about y axis I am going to tilt. Okay, va? Okay. Now I tilt it. Okay. But I need this entire floor area above the entire plane above the floor area. Okay, va? Which is floor. This one is floor. Okay. For that I need to translate again. Okay. Now we will translate it. Okay, va? Okay. Now, now we can see. Now click simulation button. See what happens. The cuboid will be in motion, but the sphere will be rolling. Okay. Okay, wait. Okay. We have created one plane, no? This plane is respondable or non-respondable. Before I have simulate, I click the simulation button, but this cuboid is interested because I set it as static object. That's why it will be in rest. But this sphere is fall down. Why? Why? Because this plane is non-respondable. Okay, wow. Go and here you can see the plane body is respondable. The plane is non-respondable here. That's why the plane not allow it will not allow the sphere to collide with it. That's why the sphere fall down. Okay, if you click respondable, and now we can just see what happened. The sphere gone. Okay, but this cuboid is in rest state, static state. That's why it is in rest motion. Okay, if we click the stop simulation button, means it will automatically comes to original position. You can see. Okay, now the sphere came. Okay, okay, up to this clear? Any doubts? Anybody? Any doubts? If you don't have any doubts now, put a thumbs up. Okay, thank you.
Could
Okay,
you explain how did you open the scene object property domain?
okay. You have created some, we have created some shapes. Am I right? So in the shapes cuboid sphere plane, you just double click the cuboid icon. For example, this is a cuboid icon, means just double click, and we have dynamic properties here. Okay, you just click it, and you will be get. Okay,
Okay, thank you.
okay. Thank you. Okay. Now Now I'm going to explain about joints. We have various types of. Could you please, someone please tell some joints in mechanical systems, not in human body, ball and socket joints, hinge joints, something like that. No, in mechanical systems, I want. Can you someone unmute and I want someone to unmute and tell the joints. Anybody here, guys? Guys?
A joint,
Welded joints.
Okay. Then welded joint.
cylindrical joint,
Okay, very good. Cylindrical joint. Any other?
spherical joint,
Spherical joint. Very good. Okay, nice. Super, guys. In CoppeliaSim, we have three joints. Pa. Okay, ba? You can, wait. I will, I will create new scene. You go to file, top corner, it will be there. Yeah, file. Click new scene. New scene will be added. Okay, this is how to create new scene. And okay, now click add. Here it will be joints will be there. Okay, wow. Joint, revolute joint, prismatic joint, spherical joint. Okay, revolute joint means it is like hinge. We can in our home door will be there. No, it will be hinge. It can allow it's fixed. It can allow motion. It can move in about fixed axis, its own fixed axis. And prismatic joint means it can move. Along its own axis, linear axis, and spherical means it can move 3D. Okay, wow. Yesterday, day one CoppeliaSim workshop, we have conducted introduction to robotics. Okay, in that degree of freedom, I think degree of freedom is taught. Yeah, taught by Bhavana or Nishwan. I don't know. Okay, okay. Can you please Tell the degree of freedom for revolute joint, prismatic joint, as well as spherical joint. Anyone? Or put it in the comment box.
Spherical joint degree of freedom is 3.
Very good, nice, super. Very nice. Your name is Hari, right? Yeah, very nice, super. Then revolute joint. Any guess? Anybody?
1.
One only. Prismatic joint. Prismatic joint also one down. Okay. Okay, I will show. Now I am going to create like this. This is a joint. I will teach how to create. Okay, this is what we are going to do now. Okay, we will add first shape. Two cuboid I'm going to add. Okay, wow. One I have added, and if no need to add, click again and add and remove the shape and clicking cuboids. No, nothing. No, don't worry. Just copy this. Control C and click Control V. It will be copy and pasted. Okay, wow. But where is the cuboid? It will be placed in the center of the floor. The first cuboid is hidden that second cuboid. Okay, wow. So for that we have to use translation. Yeah, it will be okay. If okay, now we are going to introduce one more object that is nothing but joint. I am just going to use revolute joint. Revolute joint also already formed, but it is not visible. Okay. Okay. For that, we have to translate about x z axis is easy. Okay. This is a revolute joint. Okay, ba. Okay. Now I am going to insert this joint in this what cuboid. For that, here a parent frame and world parent child we have discussed. No, here it will be played very major role. Okay, I am just going to make this joint revolute joint as child of a cuboid. Okay, now I am going to okay, now this revolute joint okay, now I'm click mouse translation and go to position. X-axis, y-axis, y coordinate, x coordinate will be 0. You just click Z as 0. Why it is it is inserted inside the cuboid? Because we have changed this revolute joint as child of the cuboid. That's why it is whatever changes we have made. Uh, we have translated. No, it is translated about its parent frame. Okay. Okay, but I need this joint slightly or slightly upper. So for that, I'm going to translation and z-axis. Just click some point one or point one. Point one is okay. Okay, wow. Okay. Here we need to set it as parent frame. Then only it will be inserted in the cuboid. If you if you have clicked world means it will be rotated, it will be translated about the world frame. Okay, this frame you can see this axis, coordinate axis here. Okay, wow. Okay. Now I am going to insert this cuboid, another cuboid. No, that cuboid into here. Okay, wow. For that, what changes I need to do? Okay, I will tell now. We need to change this cuboid is as a child of the this revolute joint. Okay, okay, change this. Okay, now the first cuboid is parent and the second cuboid is child of the first cuboid, and the second cuboid is uh, child of the revolute joint. Okay, okay. Now you just translate. Okay, now yeah. Again translation way I'm clicking. Okay. Position, click 0. Enter 0. It came on. Okay. But we need this cuboid slightly in upper position. For that, just click translation. About parent frame only we are going to do. Okay. This is z axis. We need to change this cuboid in this direction. For that, I need to change the z coordinate. Point 2. No, it will more. Point 1 is enough, I think. Okay. Now it is in setup. Okay. This is how we need to this is how to add uh, joints and joints. Okay, this is how to similarly prismatic joints also we can add instead of what revolute joint we can add prismatic joint, and we can add spherical joint. Okay, you just simulate it, nothing happened. Okay, wait, now I have already created it is similar way only pa. Like we have attached two cuboid between, yeah, we have you we have already we have attached this two cuboids between the we have yeah, a revolute joint. Okay, this is revolute joint, this is prismatic joint. Similarly we can do like this is spherical joint. Similarly we can do, we just see here prismatic joint, spherical joint. Okay, now start simulation. This prismatic joint is nothing but the motion within its axis, linear axis. That's why that uh, what that first cubite, second cubite came come down, and here it is what spherical joint. The spherical joint will it can move in 3D direction. That's why it is tilted. Okay, wow. It can tilt in any other angle, but it is not linear translation of motion. It will be rotation only. Okay, this is what three joints play major role in CoppeliaSim software. Okay, now we are going to build this. This is what a quad board we are going to build now. Okay, this have a body and our chassis. We can say chassis, and this is a wheel. We have some joints. After this we will simulate it. Okay, some internet issues I think. Okay, now we are going to build. Shall we start? Up to this clear? Any doubts, anybody? Okay, we will start. We will start um, creating. I will create new scene. Okay, now we are going to build that quad board from scratch. Okay, we just see this one. Okay, we have body. Am I right? This is body, right? What shape it is? Anyone tell?
Cuboid.
Very
Cuboid.
good. Okay, we need to add cuboid. Right click, add cuboid. But it is not. It is. It is not. It is not in this coordinate size XYZ. We have to alter. For that, I am just enter x coordinate as 0.5. Randomly, I am entering. Okay, 0.4 as y coordinate and point 0.05 is good, I think. Right. Yeah. How I am, yeah, you just see here. This is x-axis. This is x-axis. This is y-axis, and vertical position. This is z-axis. Okay, wow. This distance between the distance, the size of the cuboid along z-axis very. Okay, we have created, but you can see here. Okay, you can see here the distance. The cuboid is now our cuboid is in our what in the floor. Okay, wow, in the surface of the floor. Okay, but what for wheel, for we need to set we need to add wheel, no, for the wheel rotation we need some distance, that for that we need to translate along which axis. Select cuboid and
Yes,
along
Z-axis.
z axis. That's alpha. Very good. Click z axis. Now it is, this is mouse translation. I need to click position translation. Click some point one. Y point. Wait. Yeah, it comes. Okay. Y point one now. The diameter of the wheel that I have set is point two. The radius will be point one. So the distance from here to here will be point one. Why? The radius of the wheel is point one. Okay, that's why I click. I enter point one. Okay. Now it's time to create joint for wheel, attaching wheel to this keyboard. Right. Regular joint is better. Okay. Regular joint is here, but it is not visible. We need to translate. Mouse translation is enough. You can click here default. You can some step 6. Okay. We have to, yeah. Now it is visible. Okay. We have to insert this joint in this corner, right up. For that, previously I told we need, if we want to attach joint, if we want to connect an object with a joint, means we need to set it as a parent frame, child or child, right? So we need to set this reverse joint as child of the cuboid. Okay. Okay. Now it's created. Now now this joint will be somewhat thin. So for that, double click this icon. You can change the length and diameter of the joint. Now length will be point 0.2 is good, I think. Okay, diameter it can be 0.05. Okay, now it is okay. Okay, it will be decent. Okay. Okay, now I'm going to similarly select this joint and set all the coordinates to 0. Then and only this joint will come here. Okay, you click enter. Wait, before that I forgot to click parent frame. Okay. Wait 1 minute. Okay. Joints in horizontal position, right? In the y direction. But we have the joint. Wait. We have joint. Oh yeah, we have vertical joint. For that we need to rotate. No, we need to rotate about 90 degree. Am I right? So click orientation. And click, first of all click rotation, and again just click orientation. Click 90. Yeah, it is tilted. Okay, wow. Now click translation and set all the coordinates at 0. Yeah, about parent frame, no? Yeah, take about parent frame. Yeah, it is now in the center position of the cuboid, right? Okay, now we need this joint here now. So we need to translate this revolute joint in this direction. What is this direction? This is x direction. Am I right? Okay. So go to yeah, go to translation and position. Click point 2 here. Why it is coming like this? Because this is positive. You just see this is positive x direction. This is negative x direction. We have we are doing translation about parent frame. So this is the center of this. This is the center axis for the revolute joint. If you want to move this revolute joint here now, we need to add minus point, right? Sorry. Yeah. Now it is coming. But now we need to extend this joint here. For that, it will be in y direction, right? Yeah, y direction. Yeah, you just go to y direction and click some. You can consider point 1. No, minus point. Oh, point 1 also not enough. Yeah, minus point 2. Yeah, now it's came. Okay, okay. Now what should we need? What should we do? Yeah, we need to add wheel. For that, I'm going to create a shape. Which shape I can create? Cylinder. Okay, the cylinder dimension will be the in x-axis. It will be y in x-axis. X-axis is the diameter axis. Diameter of the cylinder. As I already said, diameter of the cylinder will be 0.2. Am I right? So click enter 0.2. And z-axis, the thickness, that height will be somewhat small. It can, yeah. So for that I need to click enter 0.05. I'm just entering. Sorry. Okay. Click enter. Okay. Now it is already there. We need to translate it about. Okay. The wheel also in horizontal position. We need to change this into vertical position. For that, we need to rotate about 90 degree. Click parent frame. Which parent? We have to add this cylinder to this joint. For that, we need to add this cylinder as a child of the revolute joint. Okay, now we have added. Okay, wow. Okay, now we just enter, click parent frame and yeah. Now mouse rotation or orientation. Now it is already 90 degree. 180 degrees will be better, I think. Yeah. Okay. Now it is in vertical position. Okay. Just go similar position, change all the coordinates into 0, 0, 0. Okay, it came here. Why? This is a parent of the joint is a parent of the cylinder. Okay, we have translated, we have changed the position about the parent frame. Okay, okay. Uh, now this wheel should be somewhat here. Am I right? So for that, I'm going to translation and position. Yeah, position. In this direction is nothing but y direction, right? So for that, okay, negative. This is positive y direction. This is negative y direction. So for that, I am going to do some wait minus 0.1. What happened? Wait. Okay. Nothing. We have added this. Wait. see this revolute joint. I said revolute joint is a parent of this sphere. If you need to monitor, if you need to change the position or dimension of this cylinder, means we need to change it out parent frame. Okay, the x-axis, x direction or y direction of the cylinder will be different because we have already tilted about 90 degree or 180 degree, 180 degree, I think 180 degree. So that's why the quad axis will be, axes are different, right? But uh, we are translating this cylinder about this its parent frame. Am I right? So we need to consider this revolute joint. You see, this is a z direction. Now up above upper vertical, this is a y direction, this is z direction. Okay, so if we need to translate this sphere here now, we need to go to position, we need to change the cylinder. Okay, we need to change z direction. Okay, click point one. Point one is enough, I think. Yeah, but it is not. The joint gap between this body and cylinder is will be more. So for that, I am going to point 0.5, 0.05 like that. Okay, now is, but it is also somewhat. 0.8 is right now. Okay, 0.7 is no. Okay, now it is 9. Okay, up to this, okay. Everyone clear? How to add wheel and joints? Okay, okay. Similarly, we have to add like this, but we don't have that much patience, no. For that, I'm just going to copy paste. That's all. Click Control C, Control V. That's all. Okay. For, yeah, we need to the another revolute joint and cylinder is here. Okay, we need to translate it. Before that, this four wheels already, yeah, the four wheels are the child of the chassis. Am I right? Then and only it will be right. So I am going to add this revolute joint and cylinder. Okay, now you just go to translation, position. You just see already we have created one cylinder and joint, and another cylinder we have copy pasted. No, that cylinder and revolute joint will be here only. Okay, we need to change. We need to change this. We need to translate that revolute joint and cylinder here. Okay, for that this is x direction. Am I right? So this is minus point 2. If we need to add here now, we need to click. We just enter plus point 2. That's all. Yeah. Okay. 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 All right. Okay. Now I'm going to, again I'm going to copy paste. It is not visible. Okay. Okay. Again I'm going to add, this is a child of the cuboid. It is added, and go to, I'm just going to uh, change the position of this part, which means we have already this third revolution and third cylinder into this place. Am I right? So for that, x direction will be same, x position, x coordinate position will be same, but y direction, y coordinate we need to change, right? Okay, this is point 2. So click enter plus point 2. It will be nice. Yeah, why this the cylinder is a child of the revolute joint. Am I right? So we need to change the dimension of about its parent frame. Okay. We'll do now. Okay, wait. I will. Okay. Now the cylinder I need to fix it. Okay. Go to translation, position. Yeah. Just see here the axis of the revolved joint is, this is y axis, this is z axis, this is x axis. Why we have tilted into 90 degree? That's why. So about this axis we need to um, translate. Am I right? Okay. Now click cylinder, go to translation, and in that this is what? Wait a minute. I forget the axis of the revolved joint. Okay, this is z axis. Okay, we need to change this into in that side, so we have to translate it both z minus the direction. So now click. Okay, minus point one is enough, I think. Yeah, enough. Yeah, wait. You will see whether this. You can see here the distance between here is small, but here is big. So for that I'm going to, again I'm going to translate 0.05. Sorry. Yeah. Okay, I deleted the cylinder. Okay, now I'm going to copy the cylinder. Okay. I'm going to change the cylinder into the parent of the, see, child of the joint. Okay, here it will be there. Okay, go to translation. Point minus point 2, but it is too long, no? Okay, for that I'm going to change 0.1, 0.05, 0.7. Previously we have gave 7, no, same dimensions. Yeah, yeah, now it is okay. Okay, similarly we have to add here. Okay, for that I'm just going to copy, paste, Control C, Control V. Okay, we have to add this revolution and cylinder as child of the cuboid, which means chassis. Okay, okay, we have to this last revolute joint and cylinder is here, right? We have to translate here. So for that go to translation again and again, same thing. Yeah, go to translation and click. Yeah, now it is in plus, it is in what, this direction is x direction. Now it is in the coordination value is point 2. We need to change the position of the revolute joint here. For that just click point minus point 2. That's not. Okay, wait, we will see whether all these are correct or not. Yeah, it is perfectly ready. Yeah, okay, now we can change the color. Shall we change the color or shall we change the texture? No, both are. Tell me, you guys, tell me now. Anybody? Both are okay. Color.
Ritesh Sharma has asked, can't we rotate revolute joint 2 to 180 degree?
Yeah, okay. Yeah, yeah, we have rotated that revolute joint to 90 degree, but we have rotated in that cuboid into 180 degree, right? Okay, it is already in this. Wait, I will tell. This cylinder we have created. No, the cylinder is already already rotated about 90 degree. While we are creating, I just while wait, I need to. Okay, wait, I will explain clearly. Now the cylinder is while we are creating this cylinder as wheel. This is wheel. While we are creating this wheel, it is already rotated about 90 degree. That's why I rotated into 180 degree. Okay, but the joint is in 0 degree. All the coordinates you can see while I am creating, you can see alpha, beta, gamma will be the coordinates. You can see while creating joint, and the coordinates while rotating, the coordinates are in the zero, right? Alpha, beta, gamma. But for in cylinder, alpha is in minus 90 degree, I think. Yeah, it is in minus 90 degree. That's why I put, if we again we need to, again we entered plus 99, it will be in same position. Okay, that's why. Clear?
Ritesh Sharma, it's up to you to say whether you are clear or not for the ask the question.
Bro, actually, I asked
Hmm.
about I'm placing the third wheel. Why can't we just rotate the entire revolute joint 2 plus the cylinder and we can place it? Like you were,
I'm
you
not get your
deleted it
point.
and then
I didn't get your point. Tell me again.
for placing the third wheel,
Okay.
you deleted the cylinder and then redrew it. Again added it, right? So why can't we just rotate both of them?
The third will this one, right?
Yeah, yeah.
Yes,
He's
yes.
asking why can't we just mirror it and rotate the cylinder only, rather doing the deleting cylinder and then placing a new cylinder like that.
Deleting cylinder off. I didn't get you points.
Yeah, while you are doing the third wheel, you have deleted the cylinder and copied by mistake, I guess it was.
Yeah. That cylinder. Okay, cylinder. Yeah. Why means yeah. By mistakenly I pressed backspace. That's why. Yeah, it's in that way also we can do. Yeah. By Ritesh, his name. Yeah. Okay. Wow.
Ritesh, are you clear about what you asked? Yeah. Okay. I think you can
Okay.
go to
I
the next
have
one.
chosen this way. You can choose that way also. That is also possible. Okay. Okay. Now it is okay. Now already 750. I think. Okay. Now we will, what we need to do? We need to add color. Am I right? Okay. Click color. Any color. Something.
Yellow,
Yellow. Yellow na. Yellow na every country. Right. Any color is enough.
green, blue, green. Okay, okay.
Right. Okay. Revolute joint will be in red color. It is enough. Okay. Now cylinder. Okay. We'll add. Now it is not like something. Yeah, it is enough. Okay. We will make it as red and it will be easy because the color of the joint and the wheel will be same. Now it's ready. Okay, we have ready this. We have built this bot. Now we will simulate it. Okay, for that, we'll- okay, we will translate this whole thing. Okay, click you by this whole thing about z-axis. Wait, okay, here. Now, previously we did something. No, that we sphere and cuboid. It fall down now. So like this, we will go. We are going to do. Okay. For that, I am going to add on plane like this same thing. 5 cross 5 dimension. Okay, it is added. Now I am going to okay. Now I am going to tilt this about x-axis, about y-axis, about y-axis. Ah, okay, y. Click y. Okay, okay, okay. Now we tilted. So now we are going to simulate it. Okay. Okay. Now press simulation button. Why? Why this is happening? Because the plane is non-respondable. Okay. Oh, why? Why we can't access any tools? Because it is simulation. No. Press stop simulation button and go to dynamic properties and click body respondable. Then only it will be collect. Is it not? Okay. Now okay. It gone. Stop simulation. This is how it will be. Okay. Now we will add on cylinder here. Um, whether the time will be time constraint is I think Karthikeyan whether it is possible or not I can I add
Yeah, yeah, we can do that. We can do
okay
that. Just please.
okay okay we're just going to add one cylinder, click cylinder and goes to yeah. I'm going to add a cylinder from here to here. It will be like a rod. So for that x direction, x axis will be something. It will be big. So that's why click two. Wait, two. No, two. Okay. X y will be 5. You know, no. This is very big. I think. Okay, now add cylinder. Point 2 is better. Point 3. X direction will be y direction will be 5 or 3. 4 is enough. Yeah. It is here. We have to rotate this one. So go to yeah. Now now we have to play we are going to place this cylinder here in this place. Okay, for that time we can rotate and we can translate about world frame. Okay, because this is floor only, no. Okay, no, don't worry. Okay, now world frame, yeah, click rotation, orientation 90 degree. Yeah, enter position 0. Sorry, parent frame. About world frame. Yeah, the cuboid is here. It will be, wait, I will show. You can see the cuboid is here. Now we will, yeah, now we need to place this cylinder here. Okay, for that, go to translation. This is x direction. So click enter some values. Point, um, 2 is not open. 2 not. 3, no, 3 is also very big. 2.5 is enough. Yeah, it is enough. But it is in, it should be in, it should be somewhat in upper 5. No, point 0.5 is only okay. 0.05 I think. Yeah, it's also 0.7, 1.1. Mm. Okay, now it is clear. Okay, now we will start simulation. What will happen? Just see what happened. Sorry, this is already in this edges. That's why it fall down. We will change the dimension again. This is okay. 2.2, but it is so for that I'm going to plane. Okay. I'm going to translate this plane in this direction. So x direction, click x direction. Yeah, okay. Now it is right. Okay, click simulation button. Yeah, see what happened. Yeah, this is nothing. Just this simulation without code. We can do some simulation. This is happen under gravity, under the influence of gravity, collision, some proper something. Okay, this is how it will work. Tomorrow, in the tomorrow session, you people will have how to use Lua script, how to yeah, how to program, how to control the robot using programming and coding by using Lua script. Okay, this is the okay. This is that's all about today's session. If you have any doubts now, you can ask. Ask now, guys.
Guys, if you have any kind of doubts, even if it is simple or it is kind of silly to ask, no worry, just ask it. We'll be here to clear
Yeah,
that.
we are here to discuss. We have, yeah, we are here to clear.
Right?
Yeah, wait, I will show. Thank you for your question. Now, For that, I'm going to just I'm added a go to add join favorite join. Okay. Now it is a favorite join. I'm right. Go and click this icon. Similarly, cuboid and like this length diameter. We can change it. If you want to alter anything, you just double click the icon of the object. Okay, it will be easy. Now clear up.
Yeah, thank you.
Okay, thank you. Any doubts, guys?
Guys, you can ask any other doubts or any other kind of discussions you want to put it in the ground. So, if you have any doubts, you can stay and ask, or else you are free to leave the meeting.
About task, you just tell uh,
Yeah,
Karthi.
yeah, yeah. One,
uh,
one minute,
uh,
1 minute. Yeah. Sorry. So, for today's task, we are planned to give you a task like you have to build any number of wheels, doesn't matter. You have to make a car, a wheel bot actually, to make it very technical, a wheel bot of your personal imagination. You can add a multiple kind of shapes. You can use merging concept to make some unique shapes, and you can place. So build a car of your imagination, a wheeled robot of your imagination, and you have to record it and send it to us along with your Insta ID. So based on how much complex car it is and how much creativity you have included in it, we'll be posting the best five wheel bots in our story. So just think something creative and do something. Just instead of just placing a cuboid as the robot's base, you can put something else. That's what our major plan is. So we can make sure that you have did that particular bot. If you have any queries after this meet even, you can DM us. We'll be always there to help you out throughout this workshop or throughout the CoppeliaSim software, whatever you have doubts. So just you do this bot with you and change instead of cuboid the robot's base to any other shape or depending upon your imagination. So just middle, just interrupt us, just call us or just DM us for any doubts. If you have any other doubts,
Sir, I have registered key.
Okay,
okay.
for
Sorry,
that
when I will
registration,
get when
yeah. While opening your CoppeliaSim software, it will be shown like this. I will send the photo in WhatsApp group. Okay, just enter registration key something. Okay, it will come. Okay, then through mail you got your registration key. Am I right?
yes, sir. Now only I registered that in website. When I will get that registered key through my email.
It will
Yeah,
come.
you can just go to your mail within just
It
maximum
came
of
pa.
five
It
to
will
ten
come.
minutes. You will
So
get.
yeah. Yeah, you
I
can.
can't hear.
Okay, it will come. It will come. If it is not coming, DM us. Okay, post it in the group.
Okay.
We will check. Okay, don't worry.
Okay.
Okay, that's all. If any doubts, anybody?